Hi, what if I told you just mastering these 9 design principles could make you a 10 times better developer? These are not just new solutions, they are battle-tested solutions that have been going around in the software industry and being used for decades. They are being used from mobile applications all the way to enterprise data pipelines. Here's the catch. If you don't use them properly, they can heavily overcomplicate your code, and rather than solving problems, they can make the future maintenance a total nightmare. Here, in this video, let's break down those 9 design patterns. In 1994, the Gang of 4 has written the classic Design Patterns book. And in this Design Patterns book, there's 23 design patterns in total. I'll be covering only 9 of those, which I think is most important and which I use constantly. And feel free to check those 23 design patterns in the book itself. The first pillar from our book is the creational design patterns. These design patterns help you create objects without tightly coupling your code to the object's specific implementations. So from the creational design patterns, the first design pattern is the Singleton design pattern. Singleton design pattern allows you to create a single entry of an object that you want to use high level all over your code. Think of it like a CEO and the only person that can make the highest level of entries. It's like the general usages for it are loggers within your system that you want only one thing, one part of the code, logging the one thing at a time, or you can use this for database connections. There are a couple of different usages of Singleton design pattern, and from my field, the most obvious ones I know are the airflow of XComs. Between the pipeline steps, it enables you to write down the data to a single entry point, and the steps communicate about the transformed data through XComs. It's a Singleton pattern. And also the TensorFlow extended metadata store. It does the same thing that the Airflow XComs do, and they're both design systems inspired by Singleton design pattern. So here's a simple example of the Singleton design pattern. The instance of the pattern of the Singleton and its lock, just to be able to make sure that our Singleton object is thread safe. And then we make sure that the instance of the class itself is not reinstantiable. And then we make sure that when it's firstly initialized, that it's initialized is set to true. And then whatever other value and whatever other functionality the Singleton has, we keep implementing that. The second creational pattern from our book is the factory design pattern. And factory design pattern enables you to separate the concern of creation of an object and decoupling your code from the creations of object. Think of it like an actual factory where you know exactly what goes in, but you don't know what's going on inside it, but you know what comes out. It enables you to decouple your main code from the creation of objects itself. And you can think of it, for examples for it would be, for example, parsers, the CSV parser, JSON parsers, XML parsers that you write in your code, or ORMs, object relational mappers like SQL Alchemy or Hibernate. So also here's an example of the factory design pattern. In our example, it's gonna be a factory of creation of parsers. Here's our parser abstract base class. It has a parse method, and then a CSV parser, it doesn't do anything right now, and a JSON parser. And here is our parsers factory implementation. It has a get parser function, and it decouples our code from the selection and creation of parser classes. And here is the main usage of our code. We create an instance of the parser factory. After its creation, we call the function get parser, and we get the parser we want to use, and we call the parse function that we have defined in its abstract base class. And the third creational design pattern from our book is the builder design pattern. The builder design pattern is used to construct a complex object step by step. It allows you to create different types and representations of an object using the same construction code. You can find this example, for example, in cases where you need to create an ETL pipeline in its configurations by chaining transformations dynamically rather than passing a massive constructor with dozens of parameters. I think for this, an example would explain much better. So, here's a simple example of the builder design pattern. Here is our ETL pipeline. It has an only function. It's initialized with its steps, and it has a function for running those steps. And here is our ETL step class. It doesn't do much. It's just for visualization here. And here is the important part, the ETL builder for us. It enables us to construct a complex object step by step here. It allows you to create different types and representations of an object using the same construction code. So here, with the steps and taking the pipeline itself, we can construct any type of ETL pipeline that we want. And here is its example usage. We initialize the ETL builder, and then we start building the ETL pipeline. We take our builder object, pass the function add step, extract, transform, and load, and then after adding all of these steps, we call the build function, and we have a completely built pipeline, and from the pipeline we run the run. The second pillar from our book is the structural design patterns. Structural design patterns are concerned about how bigger objects created with the smaller components of them. It decouples the creations and objects and the way they interact with each other, and it enables, through this decoupling, it enables you to create objects. When you change in one part of the code, you don't need to make changes in the other part of the code. The first structural design pattern in our lineup is the adapter design pattern, making incompatible things work together. The adapter pattern acts like a translator, allowing different interfaces to work together without modifying the existing code structure. It acts as a bridge between two incompatible interfaces by wrapping existing class with a new interface. This pattern is particularly useful when you want to use a class that doesn't have interface you need. And examples we can give for this is a data ingestion system that adapts various file formats, CSV, Parquet, and JSON, into a unified processing format. And here is a simplified example of the adapter design pattern. As you know, adapter design pattern acts like a translator, allowing different interfaces to work together without modifying the existing code. And here in our example, we have an adapter from JSON to XML parser. Here's our function for XML to JSON. Here is our class, the XML parser. It has a parse method, parses the data and returns the data. And here is the JSON adapter, the adapter class for adapting XML parser to parse JSON data. After initializing with XML parser, we call the parse function from the JSON adapter, and we return the result of the XML parser. And here is the main function and the implementation of it. We first initialize the XML parser, and then as an adapter we pass the XML parser to JSON adapter, and from JSON adapter we call the parse function and add the JSON data into the JSON adapter. And as a result and return of this, we will have XML data. The next structural design pattern is the Decorator design pattern. Instead of modifying a function or a class, the Decorator design pattern allows you to dynamically add features without altering the original structure of your code. The main idea is to wrap an object with another object that adds extra behavior to your main initial object. And examples that we can possibly give to this is a logging system that adds timestamps, formats, logs, and routes them to different storage solutions dynamically. Or other use cases are the retry decorators, especially from Tenacity, the one that I use personally. It enables you to add retry functionalities and exception handling to your API call functions. So here's an example of the decorator pattern. Here is our lock decorator. It has a wrapper, and then the function, we pass in the inputs, and then we return the result, and then we return the wrapper. This is the overall decorator implementation, the way the decorators are implemented in Python as well. And here's our timing decorator. We have the wrapper function, and as always, we add the to the function that we wrap, we add the functionality we want to add, which is the timing in this case, and then we return the wrapper function. And here is how it's used. With the add tag, we add the decorator on top of the function that we want to add in, and thanks to this, without changing the code of the process data function, we added the functionality of timing and the functionality of logging. And when we run it on our main point, it's gonna be both timing the calls and it's also gonna be logging the output. The last structural design pattern in our list is the proxy, the gatekeeper design pattern. I mean, the name is not gatekeeper. It's somehow like a gatekeeper, but proxy design pattern. The proxy acts as a middleman to your system. Think of it like a bouncer in a club. You can't just walk in, or any other call or any other object, they can't just walk into your system. The example I can give for this is a caching layer that proxies requests to a slow database, reducing redundant queries. An example would explain it much better. Here is an example of the proxy pattern. We have a database class which emulates a database in our case, and it has a query function. We have a cache proxy, and in this cache proxy, it's like a bouncer in a club, as we said. We pass in the database object, and not everyone can access the database directly. First, it has to go through the proxy. And within this proxy, we also have a cache. When a query comes in, we first check if the key of the query is in the cache or not. And if it's not, we access the database. And if we do, we directly return the cache. And here is the implementation. As you can see, we initialize the database, we initialize the proxy with the database, and then we query. And hello again from the very next day, because my camera's battery died last night. So let's continue from where we left off. The third pillar in our design patterns are the behavioral design patterns. These design patterns help objects communicate efficiently while maintaining loose coupling. And from these behavioral design patterns, the first one we're going to see is the observer design pattern. It's used when multiple objects need to be updated automatically when one object changes. And here's the example for it. So here is an example of observer design pattern. We have an observer object and we have a subject object, and they're abstract base classes. The observer object has a method called update to update the observer with the new data. And the subject class has the abstract methods of attaching the observer, detaching the observer, and notifying the observers if any new data comes in. Let me show it to you here, right here. And here are their implementations of those abstract classes. Let's assume we have a weather station, which is our subject, a concrete subject that holds the weather data. And it has a function, set temperature, and it sets the temperature, and then it notifies the observers with the temperature. We also initialize the weather station with its parent class. And also we have displays, which are the observers in this case, and they just, when the data comes in, they update and refresh whatever they are showing. And here is the example usage. We initialize the weather station, we initialize 2 displays, we attach 2 new displays, we attach the displays to the weather station, and whenever the weather station updates the temperature will be automatically updated in both displays and both observers. Second design pattern in our behavioral design pattern pillar is the strategy design pattern. It enables you to swap behaviors on the fly without writing if-else statements everywhere and all around your code. So here's an example of the strategy design pattern. In this example, we want to be able to use any sort strategy or sort algorithm on the fly without writing in our code if-else, if-else. If you have any other sort function, sort strategies or sort algorithms that you want to implement, just throw them as a strategy into your respective module. So here is the sort strategy base class. Let's add its ABC and also its abstract method. GitHub Copilot helps a lot in this. After adding it, here is the bubble sort strategy. It implements the sort strategy base class and has a sort method and the bubble sort algorithm. And we have a quick sort strategy. Again, implements the sort strategy abstract class and has a sort method and the respective quick sort algorithm. And we have a context where you will have to pass the strategies in and call the execute function on. The strategy context has two functions. One is setting the strategy and the other one is, as I said, executing, and the execute function calls the respective sort function of the strategy that you want to run on. And here is the implementation. An example data, the context, we initialize the context with the strategy that we want to run with, and from the context we directly call the execute function. We don't really care about the underlying structure of the sort, but it's just an easier way to manage this complexity rather than writing if else, if sort equals quick sort or bubble sort. And the third behavioral design pattern and the last design pattern in this video is the command design pattern. It encapsulates actions as objects, allowing you to queue, execute, and undo operations. Let's consider an example where we have a text editor which has the ability to implement undoable commands. So here is the example of command design pattern. We turn actions into objects in this design pattern. Here is the command abstract base class. It has an abstract function of execute and an abstract function of undo. And in this case, we are building a text editor, let's say. Here is the add text command. We pass in the editor into it and we add into the text via execute command. And with the undo command, we remove the text that we added into it. Here is the remove text command that inherits from the command abstract class, same as add text command. We pass in the editor, we pass in the text, and then in execution it removes the text. In undo, it adds the text. And here is our text editor. Here is the function to add the text, and here is the function to remove the text. As you can see, replace and concatenation. And here is the text editor invoker. It has the functions execute the comment, it executes the incoming comments execute function, and appends the implemented function, implemented command, which is the action as an object in this case, into history, and an undo comment. In this one, it pops the last executed command from history and undoes the command. And here is the full example usage. We initialize the editor, we initialize the invoker, we create an add text command with hello, we call the invoker, we execute the command, and to the history and to text editor the hello string is added. And then we create another add text command, we would passing the editor inside, and then world, and then the invoker invokes the execute command, and then the add command is executed. And then lastly, we test the remove command. We create a remove text command, and then we pass it to invoker, and then invoker invokes the remove text command. And then invoker undoes the last two commands. These 9 design patterns are just theoretical. They are the backbones of scalable and maintainable software architecture. If you liked any one of them, and if any one of those are your favorites, and if you want any more software architecture videos, any other design principles that you want to see in this video, please comment them down in the section below. If you're curious about the resources I use and where you can learn more about software design and architecture, please watch my previous video on the 9 books that I'm gonna be reading in 2025. See you in the next video.